Playing cards are one of the most typical ways that probability illustrations are given, and not everyone is super familiar with all of the traits of a deck of regular playing cards. So you want to make sure you know the basics about a standard deck of playing cards in order to be able to answer these types of questions appropriately. So what I've given here is a diagram, and what you will want to know is that there are four suits. Clubs and spades are black, hearts and diamonds are red. For our purposes, aces are not considered face cards because they do not actually have a face on them. And we don't even really consider them a quote number card because depending on what game you're playing, an ace could be a 1 or it could be an 11. So those are kind of their own cards. 2 through 10 are number cards. And then you have the jack, queen, and king of each suit that are face cards. Because you can get asked all different kinds of probability questions on these, and you need to know those qualities in order to get them correct. So let's practice a whole bunch of probabilities with cards, and we'll use our image here to help us if we need it. This says, find the following probabilities, give all your answers as fractions in lowest terms. Suppose you are drawing cards from a single 52 card deck. Find the probability of drawing a heart. Okay, so the probability that you're going to draw a heart, what's important, the first thing you always want to know is what's my denominator going to be? So out of these, it's always going to be 52 unless you're given some other information. That's how many cards are in the deck. How many of those cards are hearts? Well, you can go up here in your image and count them up. If I count the hearts, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of them. And that's something that after you do a few questions, you'll just start knowing that each suit has 13 cards. And then if we reduce 13 over 52, we get a fourth. And that makes sense. 1/4 of them are hearts. What about the probability of drawing a red card? So again, out of 52 total, how many of them are red? Well, you could either count them all up, or maybe you already know, well, if there are then 13 hearts, there are also 13 diamonds. That means there are 26 total red cards. And if we reduce that, we get a half. And that makes sense again. A half of the cards are red. So kind of start off with some easy ones to see how it works. What's the probability that it's not a red card? Well, we could just do 1 minus the probability that it is red. Since we already know that, we could apply a complement rule. So 1 minus the prior answer of a half leaves us also with a half. And again, I could have simply said, what's the probability that it's black? And we would have got to the same answer. But just to show you that these different probability rules, like the complement rule, still applies. What's the probability of drawing an ace? Okay, so we're getting a little bit harder here. Out of the 52, how many are aces? Well, there's an ace of each suit. So since there are 4 suits, there's 1, 2, 3, 4 aces. So 4 out of the 52. And if we reduce that, we get 1/13. What's the probability of drawing a black ace? Well, out of the 52 cards, if there are 4 total aces, 2 of those are going to be red and 2 of them are going to be black. So 2 out of the 52 cards happen to be black aces. Reducing that, we get 1 out of 26. Probability of drawing the ace of spades. Out of 52 cards, how many of them are the ace of spades? The ace of spades is just a single card. So there's only one way to do that out of the 52 different cards. And if you want to get an idea, because sometimes it's hard to really get a real feel for it, divide it out. So there is, and if I multiply it by a 100, there's only a 1.9% chance, so about a 2% probability that you're going to draw the ace of spades. If that happens to be the exact card that you need, it's unlikely maybe that's really the one. It's very unlikely that's going to be the one you draw. What's the probability of drawing a purple card? Okay, so that's never going to happen, right? If it's a standard deck of cards, then the only colors are red and black. So the probability of drawing a purple card would be, there's no ways to do this out of 52. The probability of doing that is 0. It can't happen. It's impossible. What's the probability of drawing a red or a black card? We know from part B that the probability of drawing a red card is a half. And so plus, we know that drawing not a red card, which would be a black card, is also a half from part C. And if we add those together, we get 1. So that's a probability of 1. There's a 100% chance that if you draw a random card, it's either going to be red or black. Right? It's the only possibilities. Probability of drawing a king. Any certain number or type of card, there's always going to be 4 of them. So there's 1, 2, 3, 4 kings, one of each suit. So 4 out of 52 reduces to 1 over 13. Probability of drawing a king or a jack. Okay, well there's 4 out of 52 that are kings, and there's another 4 out of 52 that are jacks. We can add that up and get 8 out of 52, which happens to reduce to 2/13. What's the probability of drawing a number card? So here's one where you have to be a little bit careful. Which ones are number cards? For our purposes, like I said, aces are not number cards and neither are the jacks, queens, and kings. Everything else has a specific number value to it. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of those for each suit. So if you multiply that out, 9 of them times the 4 suits, there are 36 number cards in the deck, and that reduces to 9 out of 13. So I'm going to write here as a note, number 2 through number 10. Those are the number cards. Probability of drawing a face card. How many of them are faces? Well, we have the jack, the queen, and the king, so these. So we have 3 of faces for each of the 4 suits. So again, multiplying that out, there are 12 total face cards out of the 52 possible cards. 12 out of 52 reduces to 3/13. What's the probability of drawing an even number card? So let's see, that would be drawing a 2, a 4, a 6, an 8, or a 10. So there's 1, 2, 3, 4, 5 ways to do that. And then each one of those ways is in each of the 4 suits. So there are 20 total of those in the deck. And let's see, what does that reduce to? 20 out of 52. If you want to see how to reduce that, so if I divide it out, I get the decimal, but remember you can always just hit math and then the fraction. I hadn't prior reduced this one for us. That's 5 out of 13. I forgot to do that one when I did it earlier. A face card or an even number card. So look, this refers back to these prior 2 questions. So let's see, a face card, there were 12 out of the 52 ways to do that. And an even number card, there were 20 out of 52 ways to do that. And then the question is always, was there a way to be both? Is there a way to be a face card and at the same time an even number card? And no, there's not. So in this case, these are mutually exclusive. There's no way for those to overlap. So there's nothing I need to subtract on this one. I can just add it all up. So that's 32 out of 52. And I didn't reduce this one either. So what's 32 out of 52 reduced? 8/13. A heart or a face card? Okay, well, let's see. Hearts is a suit, so we know that there's 13 hearts. And we also know that there were 12 face cards. Now, is there a way to be a heart and a face card at the same time? Yes, there is. So there's some overlap we're going to have to subtract out. So how many ways are there to be both a heart and a face card at the same time? That would be these three right here. There are 3 face cards that are also hearts. So right now, those have been counted twice. We need to subtract those 3 away so that they don't get double counted. That should leave us with 22 out of 52, which is 11 over 26. What's the probability that you're going to draw a heart, a spade, or a diamond? Okay, those are all mutually exclusive. There's no way to be both, any combination of those at the same time. So there's 13 out of 52 of each one of those. That's 39 out of 52, or 3/4. What's the probability of drawing a princess of clubs? Well, none of the cards are a princess. We have a jack, a queen, and a king, but no princess. So there are 0 out of 52 ways to do that, or just 0. How many ways are there to draw out not a princess of clubs? Anything except a princess of clubs. Well, I could apply my complement rule and say the probability of not doing something is the same as 1 minus the probability of doing it. So I could do 1 minus 0 and just get 1 for that. So there's a 100% chance I'm going to draw out something that's not a princess of clubs. I know some of these are sort of silly examples, especially those that are probabilities of 0s or 1s, but I really wanted you to get a look at what does it mean for something to have no chance at all of happening, and what does it mean for something to have a 100% certain chance of happening, and then everything else falls somewhere in between there. When you're doing your ORs, you want to make sure that you're looking for that mutually exclusive property or not, so that you can see whether you need to subtract some overlap or not on those.